All right, what's going on, everyone? It's Andrew Mayer here, back with another video. Today, I'm going to be expanding on the ER diagram that I started crafting last week. This week, what we've done is we've split it up into two different diagrams. We have a conceptual diagram, which is here. It's more high level, and then we have a physical diagram, which is implementation specific and really gets you into how we're going to be using this diagram to craft our SQL database. So, like I said last week, and if you haven't seen that video, go take a look. But we really wanted this COVID uh, death risk predictor to be more privacy focused. We didn't want to identify anybody's personal identity, so we're not using any name, social security number, address. Instead, what we have is a lot of information that we can use to determine somebody's risk of death from COVID, but not tied to their personal identity. So we have a bunch of different risk factors that you can see here. They're broken up for the most part into different entities. This helps provide organization to this whole scheme and also allows us to relate different groups of information that are ultimately tied back to one person. So as you can see for the person entity, there are some attributes that are tied just to the person, but really what makes this powerful is we have a person who's obviously going to work at one or more jobs, and then there's a set of attributes for each job. A person lives in a specific place, and there's a set of attributes for that place. Now, a place is going to have one or more hospitals located in or near it. So that's going to be tied into the location, and then there's attributes associated with that. And also, a person has a specific set of behaviors that they exhibit on a daily basis, and these would be answered through different questions within the web application, but there's a set of attributes that would come out of that. Jobs are located in a physical location too, so that's going to provide another set of linked information that will help us create a more accurate risk level. So, as you can see, each of these different entities has an associated risk, and all of those tie back to the total risk factor, which is going to be the output for the web application. These risks are going to be put into a formula, and that'll be spit back out at the end so the user has an idea of their risk relative to other people in their specific demographics. All right, so that's an overview of the conceptual diagram, and now we're going to look more at the physical diagram, which is much more in depth and helps us to sort of get an idea of what our SQL database is going to look like. So each entity that you can see in the conceptual diagram has now formed a table that's going to be in our database. So as you can see, the person, they're identified by a person ID, which is going to be stored as an integer, and pretty much all of these primary keys for each different entity are going to be stored as integers. That way they're easy to reference and they have a specific value. The primary keys are going to be referenced in other tables that they're related to. So for example, because person is really the central hub of information, they're going to be storing a lot of foreign keys. So you have the zip code, which ties it to the geographic location, company ID and behavior ID that tie those to the occupation risk factors and the behavioral risk factors. So just some other different data types that we decided to use for this. For the behavior, there's a lot of yes or no answers. So it's very easy to store those as Boolean data types, and then that's able to calculate that behavior risk. So the risk levels are going to be stored as integers also. Like I said, that's going to tie into a formula that's going to work to calculate the total risk, and then that's going to be presented at the end of the web application. Another thing that's important to know is the zip code. That's going to be stored as a normal zip code. That's going to help us to reference different information on the web. For example, population density and air quality. That's not stuff that the user is going to enter, but the web app is going to go fetch that from the internet and bring it back into the table to help, again, calculate that risk level that's going to tie back to the person. So as you can see now, this is a sample of what our database is going to look like. We have some sample tuples here, and they store the information which is presented in these implementation-specific physical diagrams. Some of the other fields, for example, gender, are going to be stored as strings, and most of these are going to be a drop-down menu, but obviously in the database they're going to be stored as strings. So for example, gender and other things like housing type, those are stored as strings, but again, they have certain value in the calculation that's going to help to determine the risk. So as you can see, a lot of the inputs in these other tables are also going to be ints. The stress level and hours per week are going to be rated by the user. But as you can see, like I was saying, in that behavior table, it's going to be easy to store those yes or no questions as Boolean data types, true, false. All right, so that's just a quick look at the physical diagram that I've created here and the associated tuples, as well as the conceptual diagram. Pretty much a one-stop shop for being able to plan for SQL database, which we would be using for this web application. All right, thank you guys so much for watching, and I'll catch you guys in the next video.